So today what I want to talk about is type classes, as well as a nice pattern that you can use to get around a few things, basically, and kind of lend your code to be more organized. So that's what we're gonna do here. I've already forgotten where I put it. Sorry. Boop, 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 boop. Could have sworn oh wait, no, it's at the very top. That's what I did. Have I gone crazy? I apologize. Where is it? Code. That's what I called it. Anyway, so we're gonna work through a pretty simple example of things, but at the same time I'm gonna explain a little bit more in just a moment. Basically, I have to deal with a lot of legacy code, and so you find in this code base, at least that I deal with, a lot of utility classes. So you have things like a util service class, right? Inside of it are all these methods that do things like, I don't know, make timestamp look like X. And then there's other stuff kind of floating around in the legacy where it's like, oh, make it look like Y, right? And then there's other classes that do strange things, like called like general service, so it doesn't really tell you that much about it because the general is just not the main thing. But then it also has weird things like this, like looks like blah, do this thing. And then there's like utility objects, like utils, and then it has some random functions in here. And then from also objects, and this is the main thing we're going to be talking about today, like transform utils, which convert from one class to another. So convert X to Y, taking an X, returning a Y. And then you just have bunches and bunches of these classes. And so what happens when you have this is you end up with these like transform util functions and things like that go on for hundreds of lines of code sometimes, depending on what's being done in them. But most of the time, specifically with these conversions, you're just trying to go from X to Y. And it's kind of annoying, to be honest, to deal with it. So what we're going to do here is I'm going to open up SPT inside of here. Where is code? Oh, here we go. Code type class. I'm still not used to still not really used to Sublime on Windows, so I only work with Linux. So yink. So here's our build file, and this goes up to type class. Blink. Here we go. Right, and so now we can run up SPT, and that will load for us. And we're going to change this to type class implicits. Class implicits. And then what we're going to have here, we'll make a new file, and we're going to call it transformation.scala. That's going to be one of our main bits of code here. Okay, and we're going to be doing most of our work in the console as just building up the example and things like that. So in addition to transformation.scala, just keep things organized, we'll have models.scala, and we'll just call it, we won't even bother with the package, we'll keep it all in the default. But anyway, just to have some examples of things going on. So let's say, I don't know, a web page. Okay, we're just going to make some example stuff. So you got a title, you have, I don't know, some body text, You know, this is not the most amazing thing in the world. It doesn't need to be, because this is just going to serve as an example. But yeah, and then you got some links, right? Maybe they're ink. Maybe they're raw URLs like that, or to make it more interesting, we'll do this. So have our URL, and we'll also have this text, or we'll call it link text. How about that? And yeah, and then we'll have a seek of these. So this is just an example. Okay, so there's our models. They're very exciting. And in the Scala compiler, if you're not aware of this, you can use paste and then specify the name of the file, and it will paste in the whole file for you, which is very nice. Okay, so normally what you would have to do here, if you wanted to convert this into something else, then you would write a utility to do so, right? So let's say that besides page link and web page, we have we're saving it to a database or something like this, right? And we have a different set of models for our links and things like that. Like there's an ID for each link or something like that. They're saved down as URLs, and they have link text, right? And then there's another one. That's one we'll call it DB web page. Okay. And this will also have an ID, right? It will have a title, string, body, and links. Or rather, there won't be links. This would just be basically a representation of our row in like a database kind of thing. So, okay. And so we have these various sets of classes to work with. And here we go. And we want to just load our new stuff in. And of course, I forgot to load our UUID class. So we'll just do that. And then we'll load it into SBT. So that way I can make web pages, I can do whatever, right? And so when we're writing some code, right, and we have something, some DAO or some special thing or another, but at some point in its life, the web page and the page link need to become things that be persisted down into the database, right? And so, you know, you'll probably have like a DAO class, you know, it would take like a connection or something, you know, some type of like pool, or maybe it sets it up itself. Maybe this thing takes parameters. It doesn't matter for our example. So we're going to ignore it, basically. But basically, you're going to have like def, you know, persist web page. That's what we'll call it for now, right? And it would take in a web page. Oops, I erased the wrong thing. I apologize. Okay, and so this will do something, and it will return true, right? We'll say that it, you know, it returns false or a Boolean for now, for when it persists or something like that, right? And of course, you'll also probably have, you know, get web page, right? Get web page of an ID of some kind, and then we'll go ahead and we'll do something, and you'll end up with a web page. And you know, it just have a complete example of this. We will actually, you know, we'll have a fake database for this, right? So we'll call it web page DAO, and then M, because I'm feeling particularly lazy today, and we'll have a UUID, or actually we'll just make it even easier. We'll have it be a map of UUID to DB web page. Okay, so this will be our pages, pretend for a moment, and then we will have also the links. Okay, and then we'll have DB page link, and this I might be just doing too much because this doesn't really have that much to do with what I want to actually talk about. Join table. Here you go. UID, seek UID, pages to links. Anyway, the whole reason I wanted to do that was just so I could make this thing return something, but bleh. Anyway, so in order to do this, we need to convert our web page into our DB classes. And the normal way that you would approach this is to write a function to do it, right? And that's perfectly fine. There's no reason not to do that, right? And so you might have maybe like a private thing in here that does like web page to DB, right? And it takes care of your web page, and it eventually gives you, you know, some information like a DB web page or something. And maybe you have another method that you'll use inside of this, and it'll be like web page links to DB, and you'll take in a bunch of links, or even just a link, you know, something. We'll just take in this for now, and it will return to us a bunch of page links, stuff like that, right? It's very exciting. No one really cares. But in here, you would write your usual code, right? So it's like, okay, well, I need to make this, so I need an ID for it, right? And then I need my my title, and I need my body, right? And then poof, there it is. And there I go. I have stuff, right? And then in our links thing here, we would be like, okay, we're going to transform this, right? So we'll just map over it, and it'll be fine. So we'll map over each page link, right? And then we'll construct a DB page link, again using UUID random, just as an example. You know, you might be auto inserting, you might be doing things like that, but whatever. Again, this isn't actually the meat of what we're going to talk about. I just want to build up a real-ish enough example that it makes some sense as to why you might do this. Okay, so we have these helper methods, right? And they're inside our little DAO, and that's fine. You know, it's a decent place for them to be, organization-wise. But this class, right, is going to get a lot bigger, especially when you add in everything to deal. I'm just going to delete these. Especially when you add in everything that you're doing into this. Like maybe this web page is not so simple because web pages aren't actually simple like this. But you know, you have other dependent types besides, you know, just these page links to this web page. It has like relationships, it has taxonomy, it has comments, it has all sorts of things like that. You know, anything related to it, it would get pretty big, right? And then this class here is going to get pretty big too. And when you're looking at code, it's useful to have it be focused on what you need it to be focused on. And in this case, the DAO here isn't really, its purpose isn't to do this conversion, right? Like it does it because it has to, because otherwise how would this class become this class, right? But organization wise, its main concern is inserting the data and getting the data out and then providing that up to whoever just called it, right? And so this conversion code might get put into a util, right? Like this is kind of how these things happen, right? So off it goes, it leaves, and then you end up with like some helper functions. And if you're lucky and all your transformations are actually pure in that they don't need to talk to the database to do things or something like that, then you can just put it into a segmental object and it's just your little utility object and it's fine, right? It's like, here we go. Here's my utils. It's perfect. It works great. I'm so happy. But there's a problem with this, right? The moment that you make yourself a utils class, right? So we'll even move this over for ourselves, right? We'll make a new class just to illustrate. Utils.scala, right? This thing's going to start getting big because you're going to start putting every conversion code you have into this, and eventually this class right here is going to be like 600 lines or something, depending on what your models are like, right? And how much effort it takes to transform. And so it's going to get bigger and bigger. And a little known fact about the Scala compiler is that it processes about 500 lines of code. Like, I can't remember what unit it is, but basically in the same amount of time that it takes like the Java compiler to compile, you know, a couple thousand lines or something like that, the Scala compiler can only process 500 lines of code because it does a lot of stuff, and we'll actually get to see some of that in a little bit. But basically the Scala compiler is kind of slow, and that's not a bad thing, but it does push one when you're writing code to try to you know, keep your files a reasonable length and to keep them focused. And when it comes to a general utility object like this that just does conversions, or even you could just call this transforms, right? It's gonna get big because people are gonna put everything and anything into here, anything and everything, like that. This stuff I was talking about earlier with like your timestamps being converted into some other format, all these things like this, like this object is gonna bloat, and it's gonna become huge. And so what I'm about to show you is a way to avoid that a little bit and to provide a nice human readable way to deal with this type of transformation code. So what we're going to do is we're going to make a type class. We're going to use the type class pattern to deal with this. So I'm going to start off with something real simple, and then we're going to add in a little bit more when I have the basic example. So we're going to define a transformation trait, okay? And this transformation trait is going to be rather simple. It's going to be called transform. Ta-da! And in comes, actually, why did I do st? Weird. Anyway, we'll do t and s for type and the thing that comes after that. So you'll take in a type of t and you'll return an s. That's all you have to do for this trait, right? And you say, okay, that's a transformation, because that's really what we're talking about here with these things. We're going from one type to another type. That's all we're doing. You could call this map if you wanted to. But for the moment and for clarity, we're just going to call it transform. Okay. And so next part of the type class pattern kind of thing is that in order to do this, we're going to provide some nice little the rest of the framework for the type class. So we're going to have an object called transformation, which will be like the introductory point for people who want to use it like this. And we're going to call it transform because we're not thinking too hard about this. And you should have it describe what it does. Okay, and so we're going to transform from type t to s, and as you might expect, we're going to take an implicit transformation of type t, which is going to be transformation of t to s, and then we're going to call it on our t. Oops, I think I forgot to, yes, I forgot a parameter. We're going to call it on our t here, and so now we can't call it t, we'll call it f. And calling this f is actually not that great of an idea, so we'll change it. We'll call it transformation implicit, just for complete and total clarity. I'm going to extend this a little bit just so everyone can see a little bit better. All right, and so just by doing this, we've actually started to build up a little framework to use. Now it's not perfect yet. Okay, so using this framework right here, we have most of the components that we want. We're going to add in something in a minute, but first what we're going to do is we're going to paste it in so you can see some of this stuff going on. Oops. Right. I screwed that up. Sorry. Apologies. Okay. So there it is. We have this transformation object now, right? And so when I say transformation.transform, and I give it a 1, and I say it's going to give me like a string, I'm going to get an error that says, oh, you couldn't find an implicit parameter transformation, implicit transformation int to s. And it's not going to be able to do it, which is a bummer. So you think to yourself, oh man, well, what do I need to do? And of course, you know, since it's looking for an implicit, that you should provide one, right? So we'll go ahead and we'll make an implicit value, and we'll call it I to S because it's a terrible name and it doesn't really matter right now. And we'll implement this trait. So we'll say here it is from a string, from int to string. And inside of it, we'll transform an int. Oh, that's an interesting thing that my that's pretty unique what it's doing there. Okay then. Anyway, so geez. Now when we call this, it works, right? And we get back a string of 1. This is not very exciting, right? Not exciting at all. So let's just go back. And the nice thing about this, holy crap. My apologies. I'm so sorry. Please go away. I don't want to see that code anymore. What's your problem? Did I spell UUID wrong? Or oh, it's because I moved this. Okay, there we go. Anyway, back into this. And so what we're gonna do is you would, for transforming web page to DB page link, we would go ahead and define a transformation for it, right? Not too hard, pretty easy, right? And so what we're gonna do is we're gonna put all this together, and so we'll paste in some models, right? Models.scala, and then we'll paste in transformation.scala, and we have that, and then we'll write some more code. So here we go. We'll just call this demo.scala. And then we'll go ahead and do this. So we'll define our implicit. And this is actually not where we're going to put it eventually. I just want to illustrate an example. And we're going to define the implicit and say, hey, I would like you to work properly. Thank you. Okay. We're actually going to be smarter about this. So for our DB page link, we're going to define the implicit transformation in here. So we'll call this page link to DB. Very exciting. And we're just going to do this one for now, and then you'll be able to see it. Yoink, 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 yoink. Transform. And we're going to transform a page link. And we'll just go ahead and we'll grab this code out. Boink. Here we go. Very exciting stuff, I know. Okay. So we'll go ahead and we'll do this. And we need this to say P, and I totally copied the wrong thing, didn't I? Yep. Okay. Apologies. When you code live, everything goes wrong. Always, without fail. Okay. So we'll go ahead and we'll call it something nice now. So anyway, now what I could do is I could be like, oh, okay. So transformation dot transform, and we're gonna go from a page link to a DB page link, and we're gonna pass it a page link, which we'll use example.com. I really hate that it's doing this on the compiler. It's awful. It makes me hate it. Example. Because now I can't even see. Where am I? Jeez, man. All right. We'll do a little bit better here. Oops. Transform from page link to DB page link. We're explicitly stating the type parameters right now, just for funsies, because you can do this a lot of different ways. You can declare it the way I did before, or this way. It will all work fine. But I just want to to work without me having to assign it, just as an example. So page link, new URL, http example.com, and then example. Yank, yank, and we'll call that, and it will work without a problem, right? The reason it works without a problem is because the compiler has 8 rules to find implicits. 1, it looks in the current scope, so that is right here when I'm typing in the console, and within your function bodies, things like that. Like if you declare a val that's implicit, then it will grab it and go. Then it also looks in the imports, and first it looks in the wildcard. Those take higher priority, and then it also looks in, sorry, no, other way around. It looks in any explicit import of an implicit, and then it looks for wildcards, and then it looks around in the same package, and it looks in companion objects. So companion objects are typically where you're going to find a lot of the implicits. And in this case, we put the implicit to convert from a page link to the DB page link inside the DB page link. And the reason that we're doing that is because this class here, we're gonna, if you for a moment pretend that we have a service, like a microservice architecture, and somewhere there's like a web page service that provides all the content for stuff, and then I don't know, we're replicating this information down to another database or modifying it or doing something like that, like making reports, whatever. It's being persisted somewhere else into like long-term storage or anything like that. So these models will exist in another library somewhere else in our code, not necessarily in the same project, in which case you do not have access to their companion objects to put the implicits in, but you do have access to your database objects. So you would go ahead and you could put it in there. Now, moving on. This isn't bad, having a, like this kind of like utility object and then dot transform. It's not bad at all, but there's a way to make this even better and also get around the fact that our types aren't actually implicit enough. You can see this when the compiler was complaining before, when it wasn't finding that implicit over here. You can see int and then s, so it still hadn't resolved what s was, even though I told it was a string. So the only reason that example actually worked was because I only had one implicit in scope. Otherwise it would have given me an ambiguous implicit. So we do need to bind the types. And in a nice way to express things is with an implicit class. So we'll go ahead and we'll call this transformation ops for some type t. Okay, and so it would take in a t, and then we'll have this beep 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 type transform into s equals transformation type t to s, and then transform into yank. And what we'll do here is we'll say implicitly give me a transformation of t to s, and then call transform on my t that was passed as a constructor argument here. Now this might seem like weird gobbledygook for just a second, and we'll go back to it, but I just want to show you what this allows us to do over here. So we'll paste in we'll paste in both things again. First we'll paste in transformation since we've updated stuff, and then we'll paste in models just to make sure everything's redeclared nicely. So we can do this again, but really what I want to do is just grab this part, but I can't. Womp womp. So here, so we'll call it p for the moment, p page link. I just want a fake page link. URL http://example.com, and then examples. Yank. shift ins in Windows, right? Yes, and then we'll wait for the compiler to have a field day. And so now we have a page link of P, right? And if I import transformation, what I can do now is I can call transform2 db page link like this, and it will work. And this this style is a lot cleaner to read than something like this, transformation.transform. Now both are clear, right? Like this is very obvious. It's like, okay, I'm using this utility object called transformation, calling .transform, do this, whatever. But as far as like reading their code, like in a few months or whatever, when you look at this and, you know, it won't say P, it will say page link, and you see page link transform2 db page link, like that is extremely clear and very human readable, and will let you instantly kind of pick up code as you go, and it will be really nice. Now, the reason we can do this is because of this implicit class. So implicit classes, if you're not familiar with them, allow you to do duck typing or monkey patching or pimping, are 3 different ways that it's described. And you can call it either. Just do some Googling, you'll find it. But basically, when you attempt to call a method that doesn't exist on a type, like we did here, PageLink has no transform2 method defined, as you can clearly see. The compiler actually goes and looks to see if there's any implicit classes in scope that take in the type we're talking about and have a transform2 method that it can use. And so once it finds that, it wraps this. So this is actually equivalent, roughly, to something like this. And then it calls transform2 db page link. Like that. Essentially is what the compiler does when it kind of unrolls your code. But it does all this automatically for you. So that's really nice. It's good. If you're not familiar with this, I know I wasn't for a while. This is a type alias that's only partially applied. So basically we've bound the type T here and left S to be interpreted. And the reason we did this was so we could use this syntax. Otherwise we would have had to write our transform2 method like this. We would still say S. That's not a problem. We would still say S. But we would take in an implicit ink. We'll just call it X for the moment. T and S like this. And then we would call it directly on T like this. There's nothing wrong with this at all. It's how you'll see things a lot, because you can only actually do this if you have one type parameter, which is why we did the type alias, to reduce the number from 2 to 1, so that we could do this, because it just reads a little bit cleaner when you're used to seeing this. So it's basically saying that whatever type you're transforming into must have an implicit transform into for that type. So anyway, let me just get rid of that. Whew. And so this is a really powerful thing, because what happens here is that the compiler is going to find the code that you need it to do your transforms without you ever having to call like a utils.do blah or anything like that, because you've just called transfer2 and it will find it. The other thing this does for you is, so let's say that db pagelink and db webpage weren't separated like this, like db webpage took in, you know, like links, but it wants links of db page links, obviously, right? Like say we did this. So go ahead, we'll save that. And now our transformations will break. So we're just gonna comment out this code a little bit. Just because I'm gonna need to rerun it and stuff. So now the transformation might need another transformation itself, right? So in models, we'll go ahead and we'll be like, oh, okay, well, I'm just declaring this thing for declaring a companion object and then making an implicit transformation, because that's what I'm gonna do. you know, db web page, or rather web page to db. That's what we'll call it. The name of the implicit val doesn't really matter at all. db web page. Oops, sorry. Web page to db web page. Okay, and we'll define it. And so for our web page, we will transform it into a db web page, and it will be great. And so this isn't too hard. This is basically what we had before, except with the exception of the other bit there. So, you know, UUID dot random UUID, the web page dot title and web page dot body, and then we'll take the web page links and we'll map it. And then here's the nice part: we'll call transform to db page link. Okay. Paste models.scala. Right. And so now what I can do is I can make myself a web page, which has a title, and it has a body, and then it has some links. So I think I called it P before, right? So we just put P together with a bunch of other P's into a list. Oops. Oh, sorry. Capital P is wrong. Web page, blah, blah, blah. And then I accidentally hit a button. And then I was dumb. I'm not sure why I was dumb. Excuse me. I don't know. Page. Oh, I think it's just because of the paste and like having loaded those models multiple times. It's probably slightly confused. But anyway, we're close though, right? So implicit value web page to DB is not applicable here because it comes after the application point and it lacks the implicit result type. Womp, womp, womp. Links, DB page link. Oh, sorry. Wait, no, that's right. Excuse me. Links, page link. I have a feeling I just have like one thing wrong and dumb here, and I'm not entirely sure what it is. Oh, duh. So in order to use transform to, I of course need to say I need to import those implicits that allow me to do that. So now I have that, and now we'll paste models in here, and then we'll make a web page. We'll call it W. Oops. Oh, right, I don't have P anymore. Man, all these things, right? Page link, new URL, / I don't know if that will actually be a valid URL or not. I can't remember about it. Oh, I did close it. What are you? Can you be okay? Fine. Oh gosh, what even? What is wrong with the? I don't even know. Windows is a strange thing to me. What is going on? Stop. Holy crap. Anyway, what we're gonna do is we're just gonna. It's just an example. Body, and then we'll make a link with new URL, http://x.com. Who knows what that is? I don't go there. There we go. Oops, shouldn't have done that. Apparently I had to go. Oh, what's up with that cursor? Jeez, man. Okay, anyway, we have a W now. And so we can import transformations. Oops. Sorry, transformation. And then I can say W transform to a DB web page, please. And it can do so. And, you can see that we have DB page links as well and everything like that. And so the nice thing is that in order to do this nested transformation here, it used the same code before. It's similar to how in this stuff, if it was set up the other way and everything like that, you could call your own functions and whatever, it will call your functions for you, or you had to do it explicitly. Versus over here, not so much, right? Like the implicits just go and find it. But this sets up a nice convention for putting the transformation code into the things that it actually relates to, So like these are the models. It's like, oh, I know that eventually I need to transform this into that. And so here it is, right? And it gets put into a very nice place. But of course it's a little bit verbose. It's just a little bit verbose. Not too bad, but a little bit verbose here, where I have to make an anonymous thing each time, saying new transformation, do this. When really, I'm just writing boilerplate here, right? Besides this part, this is all boilerplate. And so as a library writer, you want to get rid of as much boilerplate as you can, because people have other things to do than paste your examples in 5 million times. So what we can do instead then is we can make a helper method for you to construct these without having to do that part yourself. And so we'll do it one time, and then everyone else can deal with everything else. So you can see we're constructing a helper method called apply, which is special. And what we do here is we make a new transformation, T to S, in the same way that we do everywhere else, right? Takes in a T, returns an S, and then calls F on T. And that's it, right? You don't even need to do that. You can just do this and call it good, right? But now, what I have here now, oops, excuse me. Let's paste in transformation.scala. Transformation.scala, right? I have a way to write things a little bit easier. So I can say transformation. And it's like, okay, I'll put transformation. Okay, all right. And for example, let's do a Boolean. And if it's good, then we'll say hi. Otherwise, we'll say bye. This is our super awesome, exciting transformation code. Oops. Beep. Forgot my braces. I apologize. Okay, so besides, this all kind of being stuck here, you can see that I have saved myself a lot of boilerplate, and I've made a new transformation from Boolean to string that does something. So that's nice. So let's go ahead back to our models, and we'll use our apply method here. And we'll rewrite these things to have a little less boilerplate, right? So we can drop the new now, because apply is special. And we can just do this, where we can say, all right, web page. In comes the web page. Yeah, here it is, right? We can drop this extra stuff, and we can drop this. And then we can just, clean up our code a little bit, and call it pretty good. And assuming that the compiler can actually can infer some arguments for us, we're good, right? So you can see the difference between this and this, right? I said transformation, give it a function, and then it's done. As opposed to having to say new transformation, declare the types here, then do transform, repeat my type here, and just a lot of cruft. I can drop off a whole bunch of stuff to just express myself more succinctly. I can't say that word. Okay, but you know what I mean. Express yourself with brevity, because brevity is the, what is it, the soul of wit? I can't remember the saying. Anyway, but you can see, there we go, transformation does this, etc. And that's really nice. Now I'm gonna do some compiler abuse in a minute, just to show you what you probably shouldn't do. But this is all you really need, this little bit, to get started in doing this type of pattern. Because now in, you know, our fake DAO that I removed earlier, we would have things like, okay, like insert blah, right? And then inside of this, you get your like web page and stuff as arguments or things like that. And you're like, okay, I need it to go into becoming the DB page, like kind of thing. And then poof, right there it is. And I have the stuff I need in order to put stuff into the database, right? So let's like the data to insert, and then there it is, right? And whenever someone's like, oh, we're transforming that type to this type. All right, let me just go look for the companion object for this. Okay, here it is. And then you're good. You don't have to put it into the companion object. It's just a pretty like nice place. You could also store each of these implicits into like a package object, or if you want to be more explicit about your implicits, you could put each one of these into like its own object or something like that within a package, and then you could like import, you know, like something that says like transformation implicits dot underscore, and then you have all of them in scope. You could even just put all these into like your database, your DAO's package object, but then you're getting back towards that like util class that gets a bit too long, and so I would recommend putting your transformations into your companion objects for the things that they are converting into. That way you can establish that as a convention, and then everyone can go look for it, and all the code can be standardized and nice and happy. Now, all this said, you can do some other pretty fun stuff with this. So like this is good thing to start with. Because you're using implicits like this and whatnot, you can do some pretty fun things. So here, I just wanna show you how badly I want to show you what not to do. Okay, so the transformation from T to S is actually exceptionally similar to something else. Specifically, it's extremely similar to function. So the function type itself, right? Oop, not the companion object. Sorry, function one, which takes in an input argument and result type, right? And you just have to define apply, and then you can apply the function. And the thing about the Scala compiler is that when you have a type passed somewhere and it's the wrong type, the compiler tries to find an implicit function from that wrong type to the right type, and if it finds it, it will apply it automatically to you, right? And what this means is that we can do some horrible things. So let's just call this compiler abuse, because that's really what we're doing here. And so instead of transform, right, we could have this alternative thing here. And instead of taking in an implicit transformation, it takes in an implicit function of T to S, right? And then it applies T to S, and then you get the result. Like now this is nothing special. Like this is barely changed at all from what we had before. You don't even really need to write this. But what you can do here, because it's functions and things like that, is if you were to declare it, like I'm wrestling with showing you this because I don't actually want anyone to ever do this. But basically, let's say that we have some method, right? X, and it takes in, we'll do a web page. It takes in a web page, and it does some stuff. Or sorry, it takes in a DB webpage, and it does some stuff. Worked fine. If you define your transformations as functions, basically, like instead of transform here and everything like that, like for this stuff, you were to just put in function, then the compiler will actually go find things for you without you ever having to call transform to. And yeah, it's pretty fun stuff. I think I have an example. I think sorry, I'm looking through a little bit of the code. Okay, no, I didn't save that. But basically, if instead of an implicit val, we declare things as implicit method, then we could do some pretty weird things. So yeah, no, I'm not gonna bother showing you this. But this gives you a nice little starting point to apply this pattern. Now, what you can also do is you can make this even more expressive. Okay, so this is fine. This is a transformation. Great, I like that. It's good. It works, right? But if we wanted to be honest with ourselves, there's two types of transformations in the world, right? There's pure transformations, which are what you've been seeing, and then there's stateful ones. Oops. And so they're not created equal, right? So let's just do this trait, and we'll call it stateful. Okay, fine. Transformation. And there's nothing different about them except the name. That's it, right? But what we can do is we can continue to build up our little DSL here, and we could say things like, we could either say transform pure, or we could also say like purely as, or just pure. I don't know, whatever. But we're going to just use transform pure for the moment. And then we'll update this business here. We'll just make a couple. Purely and statefully. You don't have to do this, but I just really prefer this style. Okay. Purely. And then this is implicit implicitly transform into purely of t, or sorry, of s, since it's the other one. Transform t. Oh, okay. And then, of course, you would have the other one. Transform statefully s. Transform into statefully of type s. And then we'll pull it into scope via the implicitly command here, and then we'll do this, right? Okay. And then we'll go ahead, transformation.scala, make sure that we didn't mess up. And I did mess up because I forgot my type parameter there. And I forgot it somewhere else too. 54, it said. I think it was lying to me. Oh, right. It doesn't need it there. What am I thinking? It doesn't need it there. Okay, anywho. So now we have pure and stateful transformations. And the reason why this is kind of useful is because it makes it more clear that what you're about to do has no side effects, right? So this is all good and all, but it's just a transformation. So let's go ahead and make it more obvious. So transformation purely. FP to S. Now this is, the same code as the other stuff. There is no real difference here between this stuff at all. It just happens to be, instead of saying new transformation, we'll say new pure transformation. Ooh. Again, this is all just naming, but it's naming with the purpose of making it clear to whoever is reading the code that something does or does not have a side effect. Okay. Okay, there we go. And so now over here, instead of saying transformation like this, I could say transformation.purely. And same here, because both of these are pure transformations, right? And it could not be purely, it could be pure if we preferred it that way, because then it could say transformation.pure like this, and that reads fine too. So the statefully one, though, you're probably not going to ever use this for, because the way this one's going to work is a bit different. So let's pull in an example of this. So let's say that this ID wasn't as simple as this, right? Let's say you had to make like some call out somewhere because you had a terrible idea one day and you decided that there was going to be a single service that you ask for all your IDs for everyone ever or something. I don't know what, but let's assume that you did that. In that case, you would need a stateful transform, but you would need to take in this exciting thing that can get this stuff for you, right? So let's call this an ID service, I suppose. Oops. Ew. Really not used to this. Okay, transform class ID service, right? Get next ID, and it's stateful, so we'll just do this. Pretend that this is more complicated than it is, right? And that's good. But now, ignore this part for the moment, and instead say that we are going to add in some stuff here. Whoa. Excuse you. Let's just paste our models in real quick. What do you want? Value pure is not an example. Yes, it is. I saved it. Alright, and web page, transform to, not found value web page. What? Oh, in here, right? Yeah. Let's just remove this silly thing. Anyway, so we have this ID service. And so what's going to happen here is that, the person working on this stuff has a web page. They've got a W. Let's see if I have it anywhere close by. There it was. Maybe. Paste models. W. Okay. They have a web page and they want to transform it into a database object, right? And so since purely is here, we can go ahead and if we import transformation, we can go ahead and call transform pure into DB web page with a lowercase thing, and it would do it for us because we defined it that way. But if all your, for some reason, if like by choice, all your database transformations were stateful because you had to go out and get this ID from this service somewhere, then you're not going to be calling transform pure, you're going to be calling transform statefully, right? And this thing's going to complain because it can't find an implicit that has a stateful transformation for that, which is a bummer. But so you'd be tempted here inside your DAO code that this could take in your DB service, right? Or sorry, your ID service, right? And inside your insert stuff, you'd be like, oh, okay, well, I know what I'll do. I'll just do this. Here's my implicit transform, right? And it's a stateful transformation. Yeek. I don't know if that actually just copied or not. It did. Okay, cool. And it's a stateful transformation. So we could say, instead we'd say transformation dot stateful, right? Statefully. Yoink. And then in comes the web page. Web page. Do this. We'll basically copy this, except for the ID service, instead of calling it random ID like this, we'll call this, right? And then we'd have a closure, right? And then we could end up calling, you know, web page, this code. Let's just indent. Sorry, I just want it to be easily readable for you. Right? So there it is. Data. Right? And then we could call transform statefully right there. And that would work because, you know, it would. And that should actually compile now, I think. If I could spell things correctly, it will. Right? And so now we have this DAO, it takes in this thing, it has a transform, it closes, but we're back to the point where we're putting in this transformation code into our DAO again, which we were trying to avoid, right? So instead, if we want to try to keep it in here, what we can do is, instead of an implicit val, we can make an implicit method, right? And we'll call this WebHTTPD for stateful. And as an argument to this, we could take in an implicit ID service as well. So this is an implicit method taking an implicit argument and then doing this transformation. Okay. So, yoink. You can do this, there we go. And then this can leave from here again, right? And the only thing we really need now is an implicit ID service, which we would take in from here. Implicit ID service. And so now we're back to where we wanted to be, where the implicit for the transformation, for the stateful transformation, is back inside the companion object where we were expecting it. And we can now transform statefully do this. And I think that we just need to do some moving. We need to also stop doing that. We keep doing, and then here we go. So I can make a DAO, or I could attempt to, and it wouldn't work because it would say, "Hey, you don't have one of those things." So I could make one, and you know, your framework would be doing all this business about making stuff like that. Excuse me, compiler, what are you doing? Are you waiting for better weather? Okay, that's cool. Thanks. Windows. But anyway, it's now moved up, right? It's like this is one file, this is another, and all your implicit transformations are here, even though you needed an outside thing because it wasn't a pure transformation. You did it, right? You took that in as an implicit ID service, and so you've declared that it's like, yeah, this needs to have that in order to do its job. But, you know, as long as you provide that, then you can call this transform statefully and it will work just fine. Holy crap, what is this? What is my computer busy doing right now? What are you busy with, man? I don't know. Anyway. But so we end up with this nice little tiny DSL, not even 50 lines of code, right? And what we've done is we've established a convention for our transformation code. We've made a small DSL for ourselves to declare our transformations easily as anonymous functions, which is something that everyone loves to do all the time. Because it's implicit, the various transformations can use each other, right? So this will use that one. It's all good as long as they're in scope. And we've even managed to make it so that it's obvious that we're going to transform something with or without state. By, instead of saying transform to, you can say transform pure, transform statefully, right? We could even just drop transform to entirely, but we'll just keep it around for now. Holy crap, I have no idea what is wrong with this thing. Are you okay? Yeah, I know it's not responding. That's why we're killing it. Windows. But yeah, and so I think that this is a pretty nice pattern. You can't actually control that someone declares a pure transformation as a pure transformation. There's no way that you can do that. But, you know, you can imply it pretty heavily to your developers and say, these are the conventions, these are the coding styles, you must do this, right? And it'll work out, and it'll work fine. People just have to import transformation, you know, and then they can call transform to and do the stuff. And it's also helpful for, like, if you have to onboard a new developer, when they are wondering where they're supposed to put their conversion code for converting X to Y and stuff like that, they're not going to be saying, oh, well, I guess I'll make a util service or something, or where's the util service, or I found these 5 different helper objects, which one of them should I put this thing in? You can say, no, we put all our transformations into this specific place, and we declare them as pure or stateful. These are the code style and the rules here. Yeah, it will work fine. And then you just call, you know, data.transform statefully or data.transform pure on it. Now, obviously, you know, this is a bit lengthy. Transform pure, transform statefully, it's a lot to write. You could, you know, say as and as with state or something. Like, you could shorten this up a lot. As is pretty common though, so I wouldn't say you should use that at all. So yeah, but that's my example in this little bit of code here. And so let me know what you think about it, I guess, because I think it seems like a pretty nice thing overall. And a good way to shrink like those util services that people seem to love to write all the time. Yeah, so let me know what you think. I hope you enjoyed this. Any questions, feel free to shoot them to me, and I will do my best to answer. All right, thank you very much. Bye.